Welcome. Today we take a new chapter, tangent and normal. So let us see what is tangent, what is normal. Suppose this is any curve and P, say x0, y0 is a point on it. Then the straight line which meets the curve only at the point x0, y0, then it is called tangent of the curve at that point. And this line which passes through x0, y0, at the same time it is perpendicular to its tangent, this angle is 90 degree, then it is normal. So basically tangent and normal of a curve at any point is straight lines. Tangent is straight line, normal is another straight line. So as because tangent passes through the point x0, y0, then its equation will be, y minus y0 is equal to m into x minus x0. So what is m? M is the gradient of the tangent at that point. It is nothing but from the curve m, from the curve find dy dx and put x is equal to x0, y is equal to y0. That will give you tangent. Similarly, normal at any point, this is again a straight line which passes through the point x0, y0. So its equation is again of that form, but m, a gradient of the normal, it is because it is perpendicular to the tangent. So actually this is y minus y0 is equal to minus dx dy at the point P into x minus x0. So this is the basic idea of tangent and normal. So it is clear that for calculating tangent or normal, the point should be known to us at which point it is tangent, at which point it is normal, x0, y0, that is there. And gradient of the straight line, tangent, should be known to us. For tangent, it is simply dy dx at that point. For normal, it is minus dx dy at that point P. So very easily we can find tangent and normal of a curve if point is given and curve is given. Besides that, there is a shortcut method for calculating tangent, only tangent at a given point of a given curve. And the process is, in the equation of curve, x square replaced by x into x, y square to be replaced by y into y, x into y to be replaced by x to be replaced by and y half of y plus y, and constant of the function to be kept intact. After that, replace. Suppose we have to find out tangent at the point x0, y0. After that, in that equation, we replace one x, there are two x, replace one x by x0 and other x intact. Similarly, y to be 1y to be replaced by y0 and this. Similarly, this by half of x y0 plus x0 y. This one to be replaced by and y this, and by that operation we can find equation of tangent at that point. For example, find the curve is say x square plus 2y square minus 3x plus 4y, minus 3xy plus 4 into x plus minus 5 into y plus 3 is equal to 0. And suppose x0, y0 is a point on it. x0, y0 is a point on it. And it must satisfy that. And equation of tangent of that curve at that point x0, y0, in order to get that, we first write this equation as x into x plus 2 into y minus x into y, it is 3 by 2 xy plus xy, 4x to be replaced by 2 into x plus x, 5y, 5 by 2 into 2y plus 3 is equal to 0. Now, in order to get tangent of that curve at the point x0, y0, keep one x intact and other x replaced by x0, so that this becomes x0 into x plus, for that 2 into y0 into y minus 3 by 2 here x into y0 plus x0 into y plus 2 into x0 plus x minus 5 by 2 y0 plus y plus 3 is equal to 0. This is the simplest possible way, I think. But mind that it is only for calculating tangent of a curve at that point. That point must lie on that. Okay. Then next we discuss one more important thing. For few particular curves, if gradient of tangent is known to us, suppose gradient of tangent is m, its equation will be y is equal to mx plus c. This gradient is known to us. Suppose it is given that it is parallel to x minus 2y plus 5 is equal to 0. Gradient of tangent is parallel to that, means its gradient is half. So m is equal to half in that case. Now, when m is known to us, then equation of the tangent for the circle x square plus y square is equal to a square is m known, y is equal to mx up to this known quantity, c, that c is equal to plus minus a into root over 1 plus m square. For the parabola y square is equal to 4ax, that c is equal to a by m. For the ellipse x square by a square plus y square by b square is equal to 1, that c is equal to plus minus root over of a square m square plus b square. For the hyperbola, that c minus b square. So here also, if gradient is known and the standard equation of circle, parabola, ellipse and hyperbola is given, in that case we can, without any calculation, we can obtain the equation of tangent. At here also it is tangent, y is equal to mx plus c. M is given gradient and value of c is this for circle and so on. Normal for circle only. Equation of normal for any circle. Suppose this is circle, center. For at any point, whether it is on it or outside it, equation of normal must pass through center of the circle. From anywhere, it must pass. That property can be used in order to find any unknown quantity given in the problem. Okay, now with that knowledge, let us solve few problems. First problem is that equation of tangent of the curve 2y is equal to e to the power 2x plus x plus 1 at the point where it meets y-axis. Y-axis means x is equal to 0. So solving this curve and y-axis, we get x is equal to 0, put it there, 2y is equal to e to the power 2, 0 means 1, it is 0, it is 1. So that y is equal to 1. So the point is 0, 1, where it meets y-axis. We have to find its equation of tangent. From the curve 2y, this is equal to, differentiating both sides with respect to x, we get 2 dy dx is equal to 2 into e to the power 2x plus 1. So at this point, so m is our dy dx is equal to half of that, means e to the power 2 into 0 plus 1 by 2. This divided by 2 is this divided by 2 is that. So it is equal to e to the power 0 means 1, 1 plus half is 3 by 2. So that the equation of tangent of that curve where it meets y-axis is equal to y at the, it meets here at the point 0, 1. So y minus y1 is equal to 3 by 2 into x minus x0. That is 2y minus 2 is equal to 3x. This is equation of tangent of the curve at the point where it meets y-axis. So options are not given. I have forgotten. This is the correct option. Next problem. If tangent of y is equal to ax plus b minus x at 1, 1 makes an angle tan inverse 2 with x-axis, then A and B are options. First option is 1, 2, 1, minus 2, 2, minus 1, and minus 2, minus 1. So actually the problem is a curve is this. Given that at 1, 1, tangent makes an angle tan inverse 2 with x-axis. First of all, it is clear that the curve passes through the point 1, 1. So it must satisfy. Therefore, 1 is equal to a into 1 by b minus 1. That is, b minus 1 is equal to a. Suppose this is number 1, an equation involving a and b. So we require one more condition, a relation between a and b. Second relation is that tangent at that point makes an angle tan inverse 2 with x-axis. So gradient of that tangent is dy dx is equal to a into 1 b minus x minus ax into minus 1, derivative of that, by b minus x whole square. That is, it is ab minus ax plus x cancels, ab by b minus x whole square. So dy dx at the point 1, 1 is equal to ab by b minus 1 whole square. As per condition, this is equal to, this is gradient of tangent, and given that it makes an angle tan inverse 2 with that, with x-axis. Therefore, we must have ab by b minus 1 whole square is equal to 2. That is, AB is equal to 2 into b minus 1 whole square. Now, from 1 and 2, we can solve A and B. Putting value of A is equal to that. From 1, A is equal to b minus 1 A, B is that 2 into b minus 1 whole square. So we get b is equal to 2 of b minus 1. That is 2b minus b, b is equal to 2. We get b is equal to 2. Putting the value of b is equal to 2 in equation 1, we get a is equal to 2 minus 1 is equal to 1. So we get value of a is 1, value of b is 2. That is 1, 2. So this option is correct. Now our next problem. Next problem is the points where normal of y is equal to 1/3 x cube minus 5/2 x square plus 6x plus 1 are parallel to y-axis. So we have to find the points on that where normal of it is parallel to x-axis. But a normal is parallel to x-axis means tangent is parallel to, normal is parallel to y-axis. So tangent must be parallel to x-axis. So tangent is parallel to x-axis. So it is given. Now for gradient of tangent of this curve can be obtained from dy dx is equal to x square minus 5x plus 6. So as per condition, x square minus 5x plus 6 is equal to 0. So that x minus 2 into x minus 3 is equal to 0. So that x is equal to 2 and x is equal to 3. So at these 2 points, tangent is parallel to x-axis or normal of that is parallel to y-axis at x is equal to 2 and x is equal to 3. So next, options. I have forgotten to give you options. The options are 0, 1, first option. Second option is 2, 17/3 and 3, 11/3. Third option is 1, 29/6 and 0, 1. And fourth option is 1, 29/6. So anyway, we get normal of this curve parallel to y-axis at that point x is equal to either 2 or x is equal to 3. When x is equal to 2, x is equal to 2, then y coordinate can be obtained from there. Y is equal to 8/3 minus 5/2 into 4, that is for 2, 10. 4, this is 4, so 2, 10 and plus 12 plus 1. That is, it is equal to 2, 3. 8/3, they together is plus 3. 17/3. So when x is equal to 2, y is equal to that. And when x is equal to 3, y is equal to 27/3, 9. Put x is equal to 3 over there. Minus 5/2 into 9. Plus 3 into 6, 18 plus 1. So that it is equal to 19/28 minus 45/2. That is 56 minus 45/2. That is, it is equal to 11/2. So when x is equal to 3, y is equal to that. So the points where normal of that parallel to y-axis is number 1, 2, 17/3 and 3, 11/3. Oh, this is 11/2. Sorry. So this is our correct answer. Now our next problem. Next problem is, if ax plus by is equal to 1 is a normal of xy is equal to 1, then which one is correct? This is a normal of that. Then which one is correct? Number 1, a is equal to b. Number 2, a by b is negative. Number C, a by b is equal to 2 and a by b is positive. So in that problem, given that ax plus b, I think it is by is equal to 1, ax plus by is equal to 1 is a normal to that. Then which one is correct? So this is a straight line, given that it is normal to that. Gradient from coordinate geometry, gradient of that straight line is equal to minus a by b. Minus a by b is gradient of minus a by b. So from there, y is equal to 1 by x. dy dx minus 1 by x square. Therefore, minus dx dy is equal to x square. This is gradient of normal. Again, this is gradient of normal. Clearly, gradient of normal from this calculation, from the point of view calculus, it is positive. For any value of x, real x, this must be positive. Therefore, we must have a by b minus a by b is positive, that is a by b is negative. So, second option is correct. Next problem. Within 0 less than or equal to x less than or equal to pi by 2, angle of intersection between the curves y is equal to sin x and y is equal to cos x is options pi by 6, pi by 4, tan inverse 3 and tan inverse 2 root 2. So this problem also is very straightforward. Two curves are given, y is equal to sin x and y is equal to cos x. So they meet, we know that within that region 0 to pi by 2, that is in first quadrant, they meet at the point x is equal to pi by 4. Very clear, at x is equal to pi by 4, y is equal to Sine pi by 4 means 1 by root 2. This is also 1 by root 2. So they meet at that point. X is equal to pi by 2. We have to find the angle between the two curves. Means at that point, angle between the tangents, angle between the curve is nothing but angle between the tangents at that point. So tangent at that point means x is equal to pi by 4. For this curve, dy dx is equal to cos x. So dy dx at x is equal to pi by 4 is equal to 1 by root 2. Now from the second curve, dy dx is equal to minus sine x. So dy dx at the point pi by 4, this is equal to minus 1 by root 2. So this is gradient of tangent of that curve, gradient of tangent of this curve. So angle of intersection of the curves is, if it is theta, then tan theta is equal to m1 minus m2, that is 1 by root 2 minus by 1 plus m1 m2. Formula of coordinate geometry. It is equal to 2 by root 2 by, this is root 2, 1 plus half, 1 minus half. So it is this is root 2, and in denominator it is half. So half can be taken as there. Therefore angle of intersection theta is equal to tan inverse that. So this option is correct. Now next problem. If ax plus by plus c is equal to 0 is a tangent of y is equal to fx at x is equal to 1, then which one is true? Number 1, a minus b f dashed 1 is equal to 0. Number 2, a plus b f dashed 1 is equal to 0. F dashed 1 is equal to c. And last of all, b is equal to ac. So this straight line, given that this straight line is a tangent of, just 1 minute, is a tangent of that curve. Now, then which one is true? From two consideration, this is given as tangent. Its gradient can be obtained from the knowledge of coordinate geometry, and gradient of tangent also can be obtained from the knowledge of calculus, that is dy dx at that point. So from here, gradient is minus a by b. Gradient of that straight line is minus a by b. From here, dy dx is equal to f dash x. So dy dx at x is equal to 1 is f dash 1. So this is gradient of tangent, this is gradient of tangent. They must be equal. Therefore we must have a by b with negative sign is equal to f dash 1. That is bf bf dash 1 plus a is equal to 0. So a plus bf dash 1 is equal to 0 is correct option. Okay, let us stop today. If you feel that this video is helpful for you, then please like it, share it, and subscribe it. Thank you.